Okay, Year 10, this is a lesson on perpendicular and parallel lines. Now, we've done this before, we did it in Year 9, but let's have another look at it. Now, if two lines are parallel, that means they have the same, they should never meet. We know that doesn't exist in our universe because we live in a spherical universe and lines will always meet in that case. But nonetheless, in Euclidean geometry, two lines do not meet. They have the same gradient. So if two lines are parallel, they have the same gradient. So in your notes, parallel lines, you need to write something. Parallel lines have the same gradient. Which means M1 of one line equals M2. Now perpendicular lines, well, perpendicular lines have got to meet at 90 degrees. And we can show, but I'm not going to here, that when you multiply the gradients, they must equal -1. Now that's how you show two lines are perpendicular. To find, you haven't seen one of these in a while, to find the gradient of a perpendicular line, so if you're given a gradient and say find the perpendicular line, to find the gradient of a perpendicular, equation, you just take the negative reciprocal. For example, if you're told the gradient is equal to 2/3 and you want the perpendicular gradient, you just turn it upside down, take the reciprocal, and change the sign. If the gradient was, I don't know, -1/2, and you want the perpendicular gradient, you just turn it upside down and change the sign. So it becomes 2 on 1, which is just 2. A third example might be one that is m equals 3. Well, the negative reciprocal of that, remember that's 3/1, so it's a third, and you've got to change the sign. Anyway, you'll get good at those because we're going to go and do a couple now. So exercise 5H, you have to do questions 1, 2, 5, and 6. So write down the gradient of the line that is parallel. And when it's parallel, this is ridiculous. It's got the same gradient. So you go ahead and do them because you should be able to pick the gradient straight away. So in the first one, the gradient's 4. So m equals 4. Look at the next one. What's the gradient of that line in B? Hopefully you've done it and you've said m equals -7. What about C? Have a look at what's in front of the x. M, what's the gradient? Well, it's the same if it's parallel, -3/4. And what about D? What's the gradient? M equals 8 on 7. It's that easy. Let's have a look at 2 though. In 2, we've got to find the gradient of the line that is perpendicular. So in the first one, m equals 3, so m of the perpendicular is negative a third. You have a go at the next one. See the gradient. Okay, so the gradient's negative 2. You need the perpendicular, so negative a half. You need to have a go at C. What's the gradient? Hopefully you said 7 on 8. And what's the perpendicular gradient? Turn it upside down and change the sign, negative 8 on 7. Have a look at D. What's the gradient? Well, m equals negative 4 on 9. What's the perpendicular? Turn it upside down and change the sign. It's that easy. Righto. Now, question 5. Remember, if you have the gradient, and a point, so if you have m and xy, you are going to use this, y minus y1 equals m outside of x minus x1. Righto. So, here we go, 5a. We need a line parallel to that. So what's the gradient? Well, m equals the number in front of the x is a 1. If there's no number there, you know it's a 1. And it's going through the point 1, 5. So what's the equation? Y minus the y value, 5, equals the gradient, m, 1, outside of x minus the x value, which is a 1. So we get y minus 5 equals x minus 1. Now, remember there are 2 ways you can write these. You can write it in the y equals form. So I'm going to take that 5 over, add the 5, and I get y equals x plus 4. Or you can bring all these things over the other side and write it in general form. Oh, sorry, I won't, because I've got to keep the x positive. I've got to keep my x positive. So I'm going to bring all these things over to the other side and write it in general form. So I'm going to have x, I'm going to minus the y, plus the 5. I've already got minus 1, so plus 4 equals 0. They're the 2 forms in which you can write it, the general form or the y-intercept form. They've done the y-intercept form there, the y gradient intercept form. So these are pretty much all parallel line, except for when we get to perpendicular. So I'll do another one. I'll do the last parallel, E. So I look at it. It's parallel to minus 4 on 5x plus a half. So the gradient is m equals minus 4 on 5. What point does it go through? 5 and 3. So now all I do, I use the formula, y minus the y value, y minus 3, equals the gradient, negative 4 on 5, x minus the x value, x minus 5. Now I'm going to multiply this 5 across here against these two. So I get 5y minus 15. And then in here, I'm going to take this negative 4, I'm going to times it by these two. Equals negative 4x. Negative 4 times negative 5 plus 20. Now, again, I've got 2 options. First of all, I'll write it in y-intercept form. So I'm going to get 5y equals negative 4x. I'm going to add that 15 over, plus 35. And I'm going to divide by the 5. So y equals minus 4/5 x plus 7. And I'm just checking the answer. That's it. In general form, I would take all this and take it back to the other side. So I get 4x plus 5y plus 5. Minus 35. And that equals 0. Because when I bring that 20 over, it becomes minus 20. Okay, so they're parallel ones. Let's have a look at perpendicular ones. So I'll do the first one, f. It's perpendicular to 2x plus 3. So the gradient is 2. So the perpendicular gradient is negative a half. That's one we're going to use. And it goes through 2 and 5. And again, I just use the formula. Y minus the y value, 5, equals negative a half, x minus the x value, 2. Multiply the 2 against these two over here and the negative 1 against these two here. So I get 2y minus 10 equals negative x plus 2. I'm just going to write this in the y-intercept form because that's the way they're doing it in the back. So I'll go 2y equals minus x plus 12. I add the 10 over. Now divide by 2. Y equals negative a half x plus 6. Because I've got to divide everything by 2. So there's, what did I say? F, just checking. There we go. And I'll do the last one because it's got fractions in it, but that shouldn't worry you. Oh no, that's in the next question. J. J is perpendicular to negative 2, 7. So the gradient is negative 2 on 7. Well, the perpendicular gradient is 7 on 2. Change the sign, it's positive. And it's going through negative 8 and 3. So my equation is y minus y value, 3, equals 7 on 2, x minus x value, negative 8. I'm going to multiply the 2 across here and the 7 in here. So I get 2y minus 6 equals 7x. Now that's going to be plus 8 because minus 8, so I'm going to get plus 56. I'm going to write it the way that they write it in the back of the book. So I'm going to have 2y equals 7x, add the 6 over, plus 62, divide by the 2, y equals 7 on 2, x plus 31. And there we go. In question 6, these questions involve vertical and horizontal lines. All right? Now, you can draw them, or you can just write whatever the value is. So let's have a look at 6. So the first one, parallel to x equals 3. So let's have a look at that. So this is question 6. And x equals 3 is a line going through 3. So it's parallel to that. And what does it go through? It goes through 6. And who cares? We don't care what other value it goes through. So 6 is about here. So it's parallel to that, and it's going through this point, 6, 1. Oh, okay. Well, it's going to be, I'll use a different colour. It's going to be that line. X equals 6. All right? So all those parallel ones, you don't even care about. So in B, you don't even care about the y value. All right? It's going to be x equals 0 in B. In the y one, you don't even care about the x value. All right? You just look at that one. It's parallel to y minus 3. It's going through y is 11. So y equals 11. Have a look at D. Y equals 7.2. Which value are you going to put it equal to? Y equals, hopefully you're going, 8.4. Righto. Let's have a look at F because it's the first It's the first perpendicular. So perpendicular, so let's draw it. So that was A, by the way. And F. And what are we doing here? Come on. E, perpendicular to x equals 7. So E, not F. Let's get our black pen back. E. So let's draw it. X equals 7. I'm not doing it to scale here. Oh, well, I am, because you don't know what's going on in there. X equals 7. There's x equals 7. Now it's going to be perpendicular to that, which means it's going to be horizontal. It's going to be y equals something. Well, what point does it go through? It goes through the point 0, 3. So it goes through 0, 1, 2, about there, 3. So it's going to be this line. Oh, y equals 3. So this time, you're taking the other value. So have a look at that. Perpendicular to x equals negative 4.8. So it's going to be y equals whatever the y value is. Well, what's the y value in the point? Negative 3. Y equals negative 3. And that's a perpendicular one, F. You do the next two on your own. Anyway, that's parallel and perpendicular lines. This, I can't emphasize how important that is in the work that we're doing. Make sure you know it, make sure you know how to use it, make sure you can write the equation of a line.